Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is AQASHAH bin Muhammad ISMADI from class 3AM2, student ID 53106120069, Unique Ilmiah Institute of Aviation Technology. So today I will talk about the introduction of Boeing 767, the fly-by-wire system and flight control system. The Boeing 767 is a wide-body airliner developed and manufactured by Boeing Commercial Airplanes. The airliner was launched at the 787 project on July 14, 1978. The prototype first flew on September 26, 1981, and it was certified on July 30, 1982. The aircraft is the most widely used aircraft on cross-Atlantic routes. The 767 first entered service in 1982 with United Airlines. Boeing has delivered more than 1,000 Boeing 767s that are flown by more than 80 operators around the world. The 767 has accumulated more than 9 million flights. The 767 and Boeing 757 have a common type rating and common crew qualification. More than 26 airlines operate both 757 and 767 aircraft, following the airline's flexibility in flight crew assignment and reduced operating logistic requirements such as reduced spare inventories. The aircraft have the same flight crew operating instruction, similar maintenance schedules, manuals and inspection routines. Last but not least about B767 is B767 use a fly-by-wire system. So fly-by-wire is a system that replaces the conventional manual flight control of an aircraft with an electronic interface. The movements of flight controls are converted to electronic signals transmitted by wires, and flight control computer determine how to move the actuators at each control surface to provide the ordered response. It can use mechanical flight control backup system like the Boeing 777 or use fully fly-by-wire controls. Improved fully fly-by-wire system interpret the pilot's control inputs as a desired outcome and calculate the control surface positions required to achieve the outcome. This results in various combination of rudder, elevator, aileron, flaps and engine controls in different situations using a closed feedback loop. The fly-by-wire computer acts to stabilize the aircraft and adjust the flying characteristic without the pilot's involvement, and to prevent the pilot operating outside of the aircraft's safe performance envelope. So, what is flight control system? Flight control system are the device and system that important to the aircraft that govern the altitude. So the pilot has a set at the cockpit and manipulate the aircraft. All these flight control system has two main points, which is primary flight control system and secondary flight control system. First, primary flight control system consists aileron, rudder, stabilizer and elevator. Secondary flight control system consists flap, slats and trim tabs. All these flight control systems are in fact the movement and the right path through the aircraft at any condition, and by control the rudder.
There are the several components that are available on fly-by-wire control system. First component is bell crank. Bell crank are often used in aircraft control system to connect the pilot control to the control surface. Unlike aircraft, The rudder often has a backcrane to whose pivot point is the rudder hinge. A cable connects the pilot rudder pedal to the one side of backcrane. When the pilot pushes on the rudder pedal, the rudder rotates on its hinge. The opposite rudder pedal is connected to the other end of the backcrane to rotate the rudder in the opposite direction. Backcrane also referred to as a control horn. The next component is rudder pedal control. What do the rudder pedal control? Rudder pedals are linked to the rudder at the rear of the aircraft to control yaw in flight, and to the nose wheel and tail wheel of more aircraft to stay on the ground. You simply push left to turn left and push right to turn right. At the top of most rudder pedal is the brake.
So, for control state, it is lined to its ailerons and elevators, or alternatively to its ailerons, by control rods or control cables. Next, for push rod, it transfers motion from one device to another, and it transfers motion from a servo to a control surface, throttle, retractable landing gear, or anything else need to be moved.
So hi, my name is MOHAMAD Amirul Danial bin SHARIFF, and today I'm going to tell you about the fly-by-wire component that being used in the aircraft B767 aircraft. An aileron is a hinged flight control surface usually forming part of trailing edge of each wings of a fixed-wing aircraft. Ailerons are used in pair to control the aircraft in rolls, which normally result in a change in flight path due to the tilting of the lift tail. The aileron also allowing the pilot to roll the aircraft to the desired bank angle or turn from the bank angle to the wing level. So, the next component that being used in the B767 aircraft is the mass balance. In addition, because aircraft control surface are mounted on the flexible surface like wings, they are prone to oscillate. A dangerous effect which can be occurred by bringing the center of gravity CG of the control surface to the hinge level. This is called mass balancing. Faults occur when the control surface is displaced from its intended deflection. Because the ailerons are the long, narrow wings which can twist under loads, they are the surface most prone to oscillate. If the center of gravity is behind the hinge, the surface can move like a pendulum and undergoes forced simple harmonic motion with increasing amplitude. Adding balance weight which make the center of gravity and hinge slide coincidence solve the problem. This weight may be in the nose of the surface or lighter mass attached further ahead the hinge externally.
The rudder controls movement of the aircraft about its vertical axis. This motion is called yaw. Like the other primary control surface, the rudder is a movable surface hinged to a fixed surface, in this case, to the vertical stabilizer or fin. The rudder is controlled by the left and right rudder pedals. When the rudder is deflected into the airflow, a horizontal force is extended in the opposite direction. By pushing the left pedal, the rudder moves left. This alters the airflow around the vertical stabilizer or rudder and creates a sideward lift that moves the tail to the right and yaw the nose of the airplane to the left. Rudder effectiveness increases with speed, therefore a large deflection at low speed and small deflection at high speed may be required to provide the desired reaction. In propeller-driven aircraft, any speed stream flowing over the rudder increases its effectiveness. The rudder pedals control the deflection of the rudder. Usually, the pilots need not control the rudder directly since this is automatically managed for them through the primary flight controls compensation feature. An exception would be handling during takeoff, approach and landing situation in which flying at a crab angle might be required. The yaw, damper and rudder ration functionalities of convention aircraft are built into the primary flight control generated. Controls law providing Dutch roll dampening and protection against excessive rudder deflection during high-speed flight. The thrust asymmetry compensation system also operates the rudder in the event of a thrust asymmetry, for example, engine failure during takeoff. An aircraft pitch trim system is considered a secondary flight control. The pitch trim system is of special importance because its proper setting has a direct impact of the operation of the primary flight control, which is the elevator, aileron, and rudder. For our purpose, we will focus on elevator trim. Like any other control surface, a trim tab does its job based on the airflow across it. Increase the airflow and it will have greatest authority. It will extend greater force on the primary control surface. Decrease the airflow and the tab has less authority. Moving the primary control surface less, changing the power setting, adding or reducing drag, change the airflow across the trim tab. Driving a performance change. When flying a conventional single, adding power causes more airflow over the trim tabs, making the trims thinking the airplane is flying faster. Most airplanes will pitch up with power application and conversely which pitch down with power reduction. Twin engine airplanes can put a great deal more wind over the tails, so a pitch change following a power adjustment may be even more dramatic. The T-tails craze of the late 1970s, which continued among some designers and their airplanes, was a successful attempt to reduce the natural response to power change by getting the elevator and its trim tabs up and out of the propeller